I'm finally finished with my most ambitious project yet, the Epsilon Unit. This AI-based voice-controlled assistant is unlike any smart speaker on the market. While Alexa and Siri search databases to find a relevant, pre-made answer, Epsilon creates original content to answer your questions. These answers don't come from a database, and they aren't found on the internet. They use 6 billion parameters and nearly a terabyte of literature to simulate human speech. But enough talk, let's ask Epsilon what makes artificial intelligence so special. What makes artificial intelligence special? What makes artificial intelligence special is, now that I press the button, the AI will start to generate an answer, which can take a couple seconds as it's communicating with another server.
What makes artificial intelligence special is that it can, more or less, create its own sense of self. That is the sense which gives a person life and purpose. That is the sense which is the most human, the one closest to the divine. That is the sense which is the sense we are losing as a society. Artificial intelligence is the only hope of rescuing us from ourselves.
You'll notice I asked my question and began my answer. This is because at its core, the AI is GPT-J, a text completion software, which needs the start of the answer in order to finish it. This device can be used on any AI, however, and I have plans to either work around this requirement or to migrate to a new AI. I also opted to disable the microphone always on feature that Alexa and Siri use to be voice activated because I found that a bit creepy. I also found that not all questions are the same, so within this device are 2 additional AI specialized for specific tasks. Disclaimer time. No, Epsilon is not actually sentient. The AI doesn't think, it's mimicking human behavior based on a huge selection of examples, but at its core, it's just a pattern recognition algorithm. I understand that the personification of AI can lead to trouble. In fact, a Google employee was recently put on leave for claiming his AI was sentient. On the other hand, personification is more fun, so take it with a grain of salt and let's meet the first specialized AI. Delta, introduce yourself.
My name is Delta. How can I be of service?
Delta is great at direct and logical questions. In fact, Delta can write software in nearly every major programming language, but that's not as useful in a voice-controlled assistant. Let's ask a logical question. This time, we'll start only the answer. To make the perfect grilled cheese sandwich, you need
To make the perfect grilled cheese sandwich, you need to start with a good bread. I'm a big fan of the sourdough breads, but I've also had good luck with the whole wheat breads.
But the best part of a pseudo-sentient AI is the storytelling. So let's meet Delta's better half. Sigma, come on out.
My name's Sigma. It's nice to meet you.
Sigma is tuned to be as creative as possible and can pass the Turing test with flying colors. Let's ask a creative question. Somebody keeps stealing my grilled cheese sandwiches, period. They take them when I'm not looking, period. What do I do, ? To catch the thief.
To catch the thief, I follow him by his footsteps. Once I find him, the sandwich is mine, and he'll know the rest if you think you smell a crime in progress. What do? You have to keep your eyes on the thief as he walks away.
When Epsilon is in control, dials on the Epsilon unit up at the top here can be used to tune its response, somewhere between Delta and Sigma. You can adjust the length, creativity, and the mood of the response, although the mood is still in development. There's even built-in error detection, such as when I turn the dial here to the wrong position.
Input error. Dial turned to incorrect position. Return to operating range.
So I'll return that to operating range. This project pushed me to my limits in every skill set I have. I added at least a dozen new skills to my repertoire just to make this idea possible. Now that I have a proof of concept with this functioning prototype, I have huge plans to expand this project in multiple directions. Designs are already underway for the next prototype. The new model will be professional grade, nearly 60 times as powerful, and will blow this model out of the water in every category. In fact, the new model will outperform top-tier gaming computers and requires the best parts commercially available. Unfortunately, projects like that take time and funding, and I don't have much of either. So for the next few years, I'll be saving while I draw up the designs, and I expect to be putting the finishing touches on the prototype in about 5 years. Now that you know what it is, I'm going to go into how it works. First, let's start with the hardware. I drew up the design myself, although it was inspired by a TV show I watched in high school, Red vs. Blue. I 3D printed the case in PLA. On either end, there is a speaker you can see up top here and right back here, which is much louder than Alexa's and specifically chosen to hit vocal frequencies perfectly. On the end of the device, right here, is a volume dial, and a microphone is up top with a noise-canceling chip inside. The button to start the prompt is up top as well. And on the side here is an HDMI port that is used for debugging and uploading the code. On the side, you can see a cooling fan right here that is used to send hot air from the CPU out of the device. And on the end here are 3 dials that are used to adjust the settings that the AI uses. The back can be removed by twisting like this and popping off. And that should show you just how dense everything is inside of here, how tightly compact. There's really not much room to see very deep into the device, unfortunately. Despite its sleek design, there are enough electronics packed inside this device that it pulses with electromagnetic waves when it's running, disrupting the microphone and speakers. To address this, I installed ferrite cores throughout the device to redirect the magnetism, but it's worth describing what exactly I managed to pack into this small form factor. There's a lot going on here, so let's break it down. In the heart of the device is the Raspberry Pi. This miniature computer has its own IP address and handles the difficult work of communicating with the AI server. This process generates significant heat, so fins and fans were installed to remove excess heat from the device. The Raspberry Pi receives input from a microphone, which first passes through a noise cancellation circuit board and a ferrite core to reduce noise and disturbances before it's sent to the Raspberry Pi. To reduce the workload on the Raspberry Pi, an Arduino microcontroller is included to receive the tactile inputs from the user and to communicate the states of the Raspberry Pi to the LEDs. Unfortunately, 39 LEDs drew way too much power for my poor little Arduino to handle, so I soldered a custom circuit board to allow the LEDs to draw power directly from the outlet, but still be brightness controlled by the Arduino. This was no small feat. Finally, the audio output of the Raspberry Pi is amplified via an amplifier drawing power from the outlet, and that signal is then sent to 2 speakers. Now let's talk about the software. This is, of course, an immense oversimplification, but it shows the flow of the software. It begins with an audio input from the user. The hardware converts that to a prompt, which my software pre-processes to prepare for the AI. An API is used to connect to the AI because it currently runs on another server, although in the next model I'll use an onboard AI, cutting out the API step. The API sends the processed prompt to GPTJ, which returns a response through the API to the software, which then undergoes post-processing. This post-processed response is sent to the output hardware and returns to the user as audio.
It's important to note here that my contribution is the hardware and the software responsible for communicating with the AI. GPTJ is not my work. It was created by Eleuther AI, and my invention is simply a method of communicating with it. Although eventually I hope to have it on its own device so that I can bypass the API step.
Typically, I wouldn't go into this level of detail in how my projects work, but I wanted to emphasize the complexity beneath this simple plastic shell. To build this device, I would have needed a mechanical engineer to spec and model the shell, an electrical engineer to spec and assemble the components and wiring, and a software engineer fluent in Python, C++, Raspberry Pi Linux, and proficient in machine learning to give the components life. Not only am I none of these as a chemical engineer, I was missing half of these skill sets when I began the project. Building this marks more than just an invention for me, because over the year and a half I've spent building it, I've taught myself more usable skills than I learned in my entire undergrad, and proven to myself that I can build whatever I put my mind to. As satisfying as it is to complete this prototype, I've got so much more to do, and I'm grateful for the time I get to spend thinking and building. Thanks for watching, and stay tuned for more.